So, ladies and gentlemen, brace yourselves for an illuminating keynote presentation that has the power to reshape our understanding of manufacturing. With over 18 years of experience in industrial automation and solutions, our next speaker stands as a thought leader with over 75,000 followers on LinkedIn that will surely raise today. He has an ability to simplify complex concepts and communicate Industry 4.0's transformative potential is unmatched. He has also been named the #1 influencer for Industry 4.0 in the world by Analytica. Prepare to be inspired by his insights in transforming manufacturing industry with 4.0. I'm thrilled to introduce Jeff Winter, Senior Director of Industry Strategy at Hitachi Solutions. Jeff, your applause, please.
Thank you.
Thank you, Jeff.
Thank you.
Thank you.
Well, good morning, everyone. I'm excited to be here today to help kick off this awesome MES and Industry 4.0 International Summit. And I think we couldn't have picked a better venue, wouldn't you agree? So my name is Jeff Winter, and I am the Senior Director of Industry Strategy for Manufacturing with Hitachi Solutions. And what that basically means is it's my job to help point Hitachi in the right direction to be a world-class digital transformation provider. And in order to be successful at that, I have to be intimately involved with what's happening in the industry, which is why I participate in so many industry associations, academic groups, standards bodies, advisory boards, and even research teams, so that I can stay current on the latest and greatest and share those insights with you. Today, I'm going to be talking about how the world has shifted and will continue to shift in the era of Industry 4.0, and what manufacturers and solution providers alike can do to thrive in this transformative time. Now, one of the things I like about my role and Hitachi in general is that although we help manufacturers digitally transform, most people forget or don't realize we also are a manufacturer ourselves. And not just a manufacturer, one of the largest in the world, the 24th largest to be exact. We have over 140,000 manufacturing employees working in over 400 manufacturing facilities in over 20 countries. We make everything from home appliances to elevators to measurement and analytics equipment for the semiconductor and healthcare industry. We make excavators, we make metal castings, and we even make components for the nuclear power industry. So we get to see manufacturing from many different views at a massive scale. And there aren't that many companies that can claim that. And I plan on sharing some of the insights that we have learned with you today. So whenever we talk about Industry 4.0, I like to make sure we're all talking about the same thing. So Industry 4.0 is the nickname or the moniker given to the fourth industrial revolution. And as its name implies, it's a revolution in the way the entire industry operates, including how everyone works within it, which usually has massive societal impacts. So far, we've had 3 major industrial revolutions. The first took place in the 1700s, where we figured out how to take advantage of steam power, and we mechanized the world. The second industrial revolution took place in the late 1800s and early 1900s, where we developed the combustion engine and electricity, and we electrified the world. The third industrial revolution took place in the 1960s and 1970s, where we developed the computer and the internet, which created unprecedented information access and connectivity that allowed us to automate the world. And Industry 4.0, the fourth industrial revolution, is the era or time we're living in right now. It's all about connecting the digital and the physical together. But here's the way I like to describe it. Industry 3.0 is about automation, or the process of reducing human intervention in processes. Industry 4.0 is about cognition, or the process of acquiring knowledge and understanding. And what separates these two is your ability to properly capture and harness the power of data. And digital transformation can be thought of as the journey and strategy to get to that vision of Industry 4.0. Now, the term was famously introduced at Hanover Fair in 2011 as part of the German high-tech strategy. And since then, it's taken hold all around the world. Unfortunately, there's no universally agreed upon or accepted definition of Industry 4.0, as it took different meanings when it took hold all around the world. Heck, we can't even all agree on what technologies are included in it. If you look at just IoT Analytics as one market research firm, they're currently tracking 17 different technologies as part of Industry 4.0. Everything from cloud computing to edge computing to artificial intelligence, augmented reality, virtual reality, IoT, blockchain, digital twin, quantum computing, 5G, just to name a few. That means it's up to every one of us, every company, to come up with our own definition, to figure out how to take advantage of all of those technologies collectively to thrive in this transformative time that we're living in right now. Now, around 4 years ago, the World Economic Forum engaged McKinsey, and they evaluated something like 10,000 factories looking for companies that were doing Industry 4.0. Initially, they found a whopping 16. And every 6 months or so, they announced the next wave, and they're currently up to 132 as of January of this year. And these lighthouse factories, as they call them, are implementing advanced manufacturing and AI-driven technology at scale and seeing significant gains. They represent the leading edge of technology adoption, and they exemplify a new production approach that's going to drive the next wave of global economic growth. But if you look across these findings, some of them are pretty interesting, and some of them are counterintuitive. I'm going to share my favorite 4 with you. First, success is not limited to just the big companies. In fact, one of those first 16 was a small Italian manufacturer that only had around 200 employees or so. So yes, small can be successful. Second, every driver of this change was external. That means no one volunteered to do this. They didn't do it for some small incremental gain. They did it because they believed they had to. Third, minimal replacement of equipment. Legacy equipment in existing facilities don't necessarily create a barrier to innovation. In fact, most of these lighthouses were created by transforming existing brownfield operations. And fourth, these lighthouses did not deploy technology to replace operators. They found unprecedented efficiency gains through transforming the nature of work by upskilling and reskilling their workers. According to McKinsey, 5% of occupations have 100% of tasks that can be automated with today's technology. At the same time, 60% of occupations have at least 30% of tasks that can be automated with today's technology. These lighthouses were able to repurpose a portion of their employees' time and skill to more meaningful work that not only benefited them as employees, but also as employers. Did you know that the Hitachi Omika Works factory in Japan was actually one of those 132 lighthouses? It's kind of cool. And we did 3 things that I'd like to highlight as part of it. First, we implemented IoT in a pretty advanced way in both the design and manufacture of our hardware that improved production lead times by over 50%. Second, we created highly reliable and scalable systems based off of an autonomous, decentralized framework in both the design and development of our software. And third, we implemented digital twins at a pretty massive level that dramatically improved our product quality. It's pretty impressive. And so are all the lighthouses. And they're all publicly available. So I encourage you to go look them up if you want to see what best in class looks like. Now, at Hitachi, we've identified 5 major areas of focus that manufacturers are putting their efforts into to realize the vision and benefits of Industry 4.0. This ultimately answers the question, what are best in class actually doing in terms of initiatives right now? And these match some of the things that Nick talked about because these are based off of the World Economic Forum findings. First, we have worker enablement. That's all about equipping your people to be more efficient and effective from the day that they're hired until the day that they leave. Second is enhancing your customer experience. This is about combining your sales, your marketing, and your service channels all together to completely change the way that you provide value to your customers throughout the entire buying journey. Third is digital innovation. This is about unlocking value through taking advantage of digital skills, tools, and methods to enhance your products, your services, and even your business processes. And this is the heart of what I'm going to be talking about here today, because if this one's done right, it can be the most disruptive. Then there's digital operations, which is really the core of a manufacturing business. This is where you deal with production optimization, improving efficiency, improving product quality, reducing costs, those sort of things. And then we have sustainability, reducing your environmental impact while ensuring long-term economic viability, yet still meeting present and future societal needs. Now, the reason I wanted to show you all this is so you can see how some of the initiatives that you're working on today fit into this bigger transformational journey. But the common denominator across all 5 of these is the digital thread. The digital thread provides access to data, universal access, as it weaves in and out of different business processes and functions to enable continuity and accessibility. Now, it doesn't matter where you start up here or if you want to tackle everything at once. The technology is there, and it works. But the biggest barrier for success I see is that deep down, I don't think manufacturers think it works. They go to test it, they go to pilot it, and they're not ready for it to work, which means they're not ready for it to scale, which means you have a change management problem, a cultural problem, not a technological problem. Because if your digital transformation is successful, and I mean truly successful, it fundamentally changes how your entire company operates, including nearly everyone's job in that company. How many companies are ready for that level of change? How many people are ready for that level of change? For successful digital transformation, people are the focus. Technology is the tool, and more value is the outcome. Consider this. According to IoT analytics, we're surrounded by a staggering 16.7 billion connected IoT devices today. And that doesn't even include laptops and cell phones. And it's these devices that are driving an unprecedented revolution in data generation. To put this in perspective, Eric Schmidt, the former CEO of Google, famously said in 2010 that the amount of data generated since the dawn of civilization all the way up until 2003 was estimated to be 5 exabytes worth of data. Sounds impressive, right? Fast forward to 2023, and according to Statista, we're staring at a mind-boggling 120 zettabytes worth of data that we're anticipated to make this year. And in case you're not familiar with those terms, to grasp this magnitude, that means that this year alone, we're anticipated to make 24,000 times the amount of data as we did in all of civilization up until 2003. Or to put it another way, we're pumping out 5 exabytes worth of data every couple hours now. That's crazy. Now, you may be wondering, but who's producing and who's collecting all this data? It's not healthcare. It's not retail. Nope, not banking or finance. It's manufacturing. According to Morgan Stanley, manufacturing collects twice as much data as the next industry behind it. And here's where reality sinks in. Of the roughly 2,000 petabytes worth of data collected since 2010 by manufacturers, according to the Industrial Internet Consortium, we have let 99% of it slip through our fingers, discarded like yesterday's newspaper. And here's an even starker reality. According to Splunk, 55% of enterprise data is a mystery, unknown, unused by anyone in the organization. That's kind of like going to explore the ocean and having absolutely no idea how deep it is. So why does this matter? Because there's gold in that data. According to University of Texas Austin, a 10% increase in data usability results in the average Fortune 1000 company's revenue increasing by $2 billion, with a B, billion dollars. And according to McKinsey, data-driven companies are 23 times more likely to acquire new customers than their peers. So in this era of unprecedented data generation, how good do you think your data strategy holds up today? Think it's good enough? So used in conjunction with IoT, today's digital twins unlock multiple capabilities. So a digital twin takes a real-life object and it creates an exact replica of that object in the virtual space. And this digital twin then acts as a representation of a system to generate data and help determine decisions about that system. And that's used to help optimize operations, validate design ideas, and even provide predictive feedback into real-time processes. Now, modeling and simulation aren't new. What makes this digital twin different is the fact that it is fed real-time information from the physical object to accurately and precisely imitate its actions and responses. And that can lead to all sorts of cool things, like creating new products the right way the first time and avoiding costly mistakes. But in addition, digital twins can provide manufacturers unbelievable clarity by creating a digital feedback loop that fosters exponential learning and adaptability. And that's extremely important today, when the only constant is change. Now, going one step further, the cutting edge, the metaverse. So the metaverse is a collective virtual space based off the convergence of your virtually enhanced physical reality and your physically persistent or always-on virtual reality. But it can be thought of as the combination of your virtual reality, your augmented reality, and the internet. In fact, early versions of the metaverse can be thought of as the anticipated next iteration of the internet that's often hailed as Web 3.0. But if all you're thinking about is avatars, you're missing the bigger picture and its applicability in the industrial setting, especially in the short term. So here's how I want you to be thinking about it. Think about the metaverse as a digital twin on steroids that combines the interaction with people, like your employees and your customers, to provide a fully integrated, fully immersive, 3D engaging experience. Anheuser-Busch InBev is a great example of this. As experts in process manufacturing, they're leveraging all these technologies in their early version of the metaverse to completely change the way that they operate, the way that they collaborate, the way that they innovate, the way that they manage, and even the way that they engage with, well, everyone. Let's take a look.
With more than 200 breweries and 160,000 employees across the globe, Anheuser-Busch InBev is the largest brewer in the world, with an unparalleled portfolio of brands and a global presence with operations in 50 markets. AB InBev is an expert in their field, and their forward-leaning and innovative spirit is leading to new breakthroughs in brewing. Through their digital factory and supply chain of the future initiatives, in collaboration with Microsoft, AB InBev is focused on transforming both breweries and their global operations by empowering their frontline colleagues with digital solutions that enable world-class manufacturing, mobility, data automation, and business insights. It begins with the brewery coming to life with AI, Azure Digital Twins, and the Microsoft Cloud. The brewmaster is responsible for making the best quality beer. She has unprecedented visibility into the brewing process, so she can predict and monitor the complex chemical and biological fermentation parameters required to produce the highest quality product. Frontline operations can remotely monitor critical quality and traceability data from the manufacturing execution systems using the mobile brewery technology built using Azure. With built-in energy and utility management solutions, the digital brewery supports AB InBev's industry-leading sustainable development goals. After the perfect batch is ready to be bottled and shipped, AB InBev extends their digital twin solution to support the packaging line operations to ensure it's done right. These can plants are adopting Azure AI and Microsoft Project Bonsai's deep reinforcement learning to deliver line balancing optimization that detects and automatically compensates for bottlenecks in the complex can manufacturing operations. At AB InBev, their 100% uptime mindset is enabled through predictive maintenance and global support. A frontline operator can efficiently address problems through remote collaboration with a maintenance technician, ensuring no unplanned downtime of packaging equipment. The perfect beer is packaged and ready. The digital technologies of the AB InBev supply chain of the future minimizes carbon footprint while making sure the right beer gets to the right customer at the right time. This beer's journey is complete, and AB InBev and Microsoft are taking bold steps into the future.
Pretty impressive, isn't it? And they're not the only ones doing this. They just happen to have the coolest video I found, and I'm a big fan of their beer. So let's talk about what's making all this possible. Innovation. So my personal favorite definition of innovation is the practical implementation of ideas that results in the introduction of new goods and services or an improvement in the way that goods and services are brought to market. Some of you may be familiar with the technology adoption curve, famously attributed to Everett Rogers. And if you're not, it's a sociological model that describes the acceptance or adoption of new products and technologies based off of characteristics of defined adopter groups. It basically explains how people and even companies behave in implementing innovative technologies. Now, traditionally, it's taken on a normal distribution shape with a bulk of people fitting right in the middle. Very few innovators. But in recent years, there is evidence to suggest that this shape is seeing a positive skew, pushing much more people into the innovator and early adopter categories. To put this in perspective, the Chief Innovation Officer role, or CINO, is something that didn't even exist 20 years ago, and now, according to Forbes, 30% of Fortune 500 companies have one in place. And if you were to go to LinkedIn, you will find over 13,000 people with this title today, and over an additional 270,000 people with innovation in their title today. So yeah, it's taking off. Because business leaders know that technological progress and market conditions are changing so rapidly that failure to react quickly can be catastrophic. So not only do we need to be innovating more than we ever have before, we need to be innovating faster. So now I'm going to talk about two of my favorite ways that manufacturers are unlocking innovation through all that data I talked about. I'm going to go over digital engineering and connected products. And first, I'll start with digital engineering. So in theory, digital engineering can be applied anywhere that product developers want to make the development process more agile and responsive to market demands. And it can be thought of as the art of creating, capturing, and integrating data using new digital skills and digital tools. It ends up building up the data that forms and informs our digital twins. But digital engineering is a fundamental component of digital transformation. And I would argue it doesn't even matter what your role is. You need to start thinking like a digital engineer. You need to embrace concepts like DevOps, and Agile, and continuous testing, and iterations, and experimentation with new and untested elements. Because the transformation from manufacturing isn't just about product definition and design, but it fundamentally changes the way that products are manufactured, assembled, delivered, consumed, maintained, and even sold. Products aren't just being designed differently, they're being designed with intelligence built in, and the customer experience as part of the sale. The cycle of delivery used to end at the point of sale, but now manufacturers are making their products relevant for years through small, continuous releases that more closely align them to their changing environments. And this changes the way that manufacturers think about sunsetting products and capitalization by extending the life of them. This is where over-the-air updates is a great example of this. Whether it's your cell phone, your laptop, your car, airplanes, and yes, even industrial automation equipment and machinery. It's already being done. The sale of hardware and products used to be the dominant way that manufacturers realized their revenue. But now, manufacturers are finding new and more ways to create revenue through data insights, digital services, and software. In fact, most manufacturers are able to create more revenue streams just by the insights gained by how their stuff is used and maintained in the field. Doesn't matter if it's B2B or B2C. The question is, are you collecting that data and using it? And lastly, engineers are not just integrating with the supply chain, but with the entire value chain. So supply chain mainly deals with the production and distribution of goods. But the value chain focuses on adding value to a product at every step of the process, from planning to design to development and delivery. Now, earlier I described how the digital thread was the common denominator across those 5 areas that manufacturers focus on. But it's what connects the digital and the physical worlds together, and it's what brings them to life. It powers how manufacturers model and understand everything from their products to their assets, to their operations, to their facilities, to their suppliers, and even their customers. Now, what's important to realize here is that connecting data silos together is only part of a digital thread. You also need to intelligently connect your data across its product and service life cycles. This is part of digital engineering. You need to be able to see your product definition and configuration not just in your as-designed state, but also your as-manufactured state and your as-maintained state in the field, enabling collaboration not just with your production engineers, but directly with your suppliers and even your customers. Now, we capture all this data and this history already. It's what makes our digital twin so effective. But imagine being able to look into an individual, serialized product, asset, or even process, and perform a rewind and a replay function to better understand how it performed. That's powerful. But now take advantage of artificial intelligence and deep reinforcement learning and conduct analysis and predict future outcomes and explore totally new opportunities. That's game-changing. Now, I recognize there's a lot of different softwares out there in the manufacturing landscape that take advantage of the flow of data. Whether it is your CAD, your MES, your PLM, your ERP, your CRM, your WMS, you didn't think I'd be able to successfully name 6 acronyms in 3 seconds and have it make sense, did you? Unfortunately, not many companies have built a digital thread or democratized their data. According to PTC, 34% of companies reported that data generated in their department was widely accessible on enterprise systems. And sadly, that's the best stat. It's going to get worse from there. 16% from data generated from other departments, 9% of data generated from customers and products in the field, and 8% of data generated from suppliers. That's not good. We can do better. Imagine if that were 100%. So let's go over an example. Rolls-Royce has evolved from manufacturing and selling aerospace engines to extending comprehensive maintenance through connectivity with their engines. And it's this data and connectivity that allowed them to create their total care service offering, or what is commonly known as power by the hour in the industry, to better optimize their operations. They use IoT to connect to their engines and machine learning to gain incredible insights, so much so that they didn't just change their business model, but they even directly helped their customers improve their operations, improve their flight plans, and even their maintenance schedules. On top of that, in October of 2021, the United States Air Force awarded Rolls-Royce the contract to build the new B-52 airplane engines. All said and done, a $2.6 billion project, and the first government E-Series bid that required full digital verification and validation. And if you're not familiar with digital verification and validation, it's one of the top priorities amongst the manufacturing industry right now, as manufacturers' customers are demanding product performance from multiple dimensions like that. In the case of aerospace engines, that could be structural integrity modeling, heat transfer modeling, fuel flow modeling, airflow modeling, power generation simulation. Physical prototyping is costly and time-consuming and still doesn't get you as much. Digital verification and validation not only speed up the product development time, but they change the way engineers operate from designing and then simulating to designing and simulating. Not only was Rolls-Royce able to meet all the requirements of their bid, they were also able to demonstrate how they lowered maintenance and sustainment burden while simultaneously increasing fuel efficiency. And they did it all in a virtual environment. In fact, their use of digital tools and skills got so good that they're going to continue to operate only 40% of their office space in their Indianapolis office because, well, the pandemic happened, their lease was up, and they were able to do most of this with people working at home. Pretty innovative. The other main area for unlocking innovation I want to go over is connected products, which really lays the foundation for a lot of cool things. And I broke this into 3 areas to get you to understand it. First is just basic connectivity. Just connect to your product. And that allows you to do things like health checks, remote monitoring, over-the-air updates, geofencing, security, that kind of stuff. But if you're connected to your product, you can start to collect data. And if you collect data, you can start to analyze it. And if you analyze it, you can start to get insights, things like product usage reports to help with new feature development and new product development. You can even understand how and when to maintain your equipment in the field, or how much life is left within it. This can then lead to new business models, where you take those insights you gained, you turn them into digital services, and you proactively offer them to your customers. Things like predictive maintenance, where you charge a premium for it. Maybe even a subscription model. And to go one step further is product as a service. Whether it's printing as a service, packaging as a service, or power tool as a service. They all exist today. Michelin offers tire as a service. ThyssenKrupp offers material as a service. Philips offers light as a service. But I understand that the journey to product as a service can be a challenge for manufacturers and even solution providers alike. Because after all, the traditional business model offers upfront cash, but little to no commitment of the customer's use of the product or asset, which makes it very hard to stay connected to them as their business needs evolve. But manufacturers today see the value of staying connected to their customers after the sale of the product, but all the way through to the disposal of the product. Now, there are 3 major steps to get to product as a service. First is digital services. Manufacturers find that adding additional services on top of their existing install base is just the least risky option. You take your data, you sell it on top of what you have. It keeps the traditional business model up front, intact. But sometimes large expenses can be difficult, so now you have the opportunity to reshape the way you provide value by offering a subscription, which not only changes things from CapEx to OpEx, but it also changes your accountability from one-time to continual. And the last is outcome-based contracts. Outcome-based contracts allow manufacturers the ability to demonstrate their commitment to their customer's business by charging for the outcome delivered instead of the product or the asset. And when you do this, it fundamentally changes your whole company. Because when you're on the hook for the outcome delivered, your incentive is entirely different. You're incentivized to pay attention to what's going on. You're incentivized to connect your products, to monitor them, and to proactively maintain them. Manufacturers are doing this. Have you started to think about it? Let's go over another example. Celli Group is a global company based in Italy that manufactures and services dispensing equipment for soft drink, water, and beer. They have about 400 employees or so in 6 different facilities, and they've implemented an IoT strategy that allows them to directly connect to their customer that not only changed their business model, but also their service delivery. They implemented a model-based system with PLM and IoT at the heart of their digital transformation journey, which resulted in a novel smart warranty that's completely unheard of in their industry. Their warranty is based off of performance against specification instead of time and service. That means their warranty changes depending on how hard and how frequent you use their equipment. That's innovative. But because they were collecting all this data, they were able to substantially increase their profits while simultaneously differentiating their offering against their competitors. And this resulted in a 14% greater sell-through rate via enhanced sales and inventory management, a 13% reduction in equipment failure, a 27% increase in product quality by measuring sanitation cycles, shelf life, and temperature, and a 10% decrease in service costs through better predictive maintenance. The key for them was having their PLM and IoT connected together as part of their digital thread, which in their case extends all the way out to their customer. There is so much opportunity here. In the age of digital transformation and Industry 4.0, there is no time to waste. Imagine if your company did half the stuff I talked about up here today. How much would that revolutionize your company? Let me ask it a different way. If your competitors did half the stuff I talked about up here today, how difficult of a situation would you be in? Remember, the technology is there, and it works. The question is, are you using it to unlock innovation? In the era of Industry 4.0, innovation doesn't just solve problems. It creates entirely new possibilities. Thank you, everyone. I hope I inspired you today for Industry 4.0. There's a ton of information out there. Feel free to connect with me on LinkedIn. I'm happy to send this to you, or I will be here for the whole conference, and feel free to come up to me. Thank you very much, everyone.
Thank you so much, Jeff.
Thank you.
Thank you. And thank you for inspiring everyone to take action.